Hi everyone, let's talk about the economics of utility maximization. We're going to start with some definitions. Utility is a measure of personal satisfaction, so how much satisfaction I derive from consumption of a product. We measure this satisfaction in units called utils. Marginal utility is the change in total utility from consuming one additional unit. Diminishing utility or diminishing marginal utility says that each additional unit consumed results in a smaller addition to total utility. Let's look at that on a graph. Well, graphically, this idea of diminishing marginal utility says that for each additional unit of a product that I consume, in this case clams, what's happening to my total utility? It's increasing, but it's increasing at a decreasing rate. Similarly, on the marginal utility curve, as you look at additional units consumed, my marginal utility decreases with each unit that I consume. So let's talk about budgets and optimal consumption. Why budgets? Well, because we can't eat as much as we want. There is really no such thing as an all-you-can-eat buffet. In fact, they kick you out at a certain point. And we only have so much money. So what we've done here is put together what we call a budget line. And the example here is Sammy. This is Sammy's budget line. These dots here represent all the combinations of clams and potatoes that Sammy can consume. Combinations here that maximize his budget, use all of his resources. Inside here, he could consume smaller amounts of each, but he's not maximizing his resource, in this case his income. Out here, unaffordable consumption bundles. This should look very similar to the production possibilities frontier. Now, Sammy can consume at any point along the line, but which is best for him? Where should he be consuming? Which maximizes his total utility or total satisfaction? In order to figure out how much of each he consume, otherwise known as the optimal bundle, we need to look at the combinations of consumption. So the combination of those points along the curve, you see A, B, C, D, E, F here, same as here. What combination gives him the greatest utility? Well, the first chart here shows us quantity of clams consumed, utility from those different amounts of consumption. Here, same with potatoes, quantity and utility. Pause if you need to look at the whole thing. Now we have Sammy's budget and total utility. Well, total utility equals the sum of the utilities of the individual products. So here's utility from clams, here's utility from potatoes, total utility is over here. All we're looking for is the combination of consumption that maximizes utility. You can look at these, look at the sums, go back to this chart if you need a little bit of review on how these numbers came together. Let's look at the same thing put onto graphs. Optimal consumption bundles. Well, here we have Sammy's budget line, similar to 2 slides ago. Here we have Sammy's utility function. So the total utility derived from this here put onto a graph. And that shows us that he actually has maximized his utility at point C. 2 pounds of clams, 6 pounds of potatoes. Note, Q in this case in a utility function, when you have more than one product, Q is going to be delineated in opposite directions. Increasing here, decreasing here. Pause if you need to take a closer look. Okay, that tells us how much to consume, but how much should we spend on each good? The decision around how much we should spend on each good is a function of the marginal utility per dollar. So now what we've done is taken marginal utility and added to it what we're paying to get that marginal utility. All we're doing is taking the marginal utility we gain, dividing it by the amount we spent to get that marginal utility. In this case, 15 divided by 4 equals $3.75 utils. I had to be careful there not to turn it back into dollars. Pause if you need to just check all this math going down here. Where do we need to spend? Well, the rule says we need to spend where the marginal utilities per dollar are the same between the two products. You'll notice here they've highlighted for a reason. In between these two and in between these two, you're going to find a measurement of utils that's actually 2. And I'm going to have a practice for us tomorrow that will show us exactly how we get to that number. But what you want to look at here is that we have 2 pounds of clams and 6 pounds of potatoes that are getting us to that number. Put that on a graph, and you can see, again, being very careful to look at quantity of one product going this way and quantity of product going that way, the optimal consumption bundle, the marginal utility per dollar spent on clams, is equal to the marginal utility per dollar spent on potatoes. So that point of intersection right there is the bundle or the combination of products that we want to consume. In this case, 2 pounds of clams, 6 pounds of potatoes. A lot to get through in one night. Very quick review. Here are some definitions. Utility function and utility curve. Diminishing, right? Law of diminishing marginal utility or diminishing marginal return. Affordable consumption bundles within a budget constraint. Looking at maximizing our utility when we start thinking about, well, how much of each should we consume? That same idea put into graphs, and here looking on the utility function at the maximized point on that utility curve. Careful of opposite directions, thinking about, okay, well, how much should we spend on each good? Well, that depends on marginal utility per dollar. And then taking the results of these simple calculations and putting them on a graph. That's it. Have a great night. See you tomorrow.